In today's video, I would like to introduce a very nice problem. Here is the following information. Find all n and k as natural numbers. Here is the following statement. N squared plus 225 equals 17 to the k. Okay? We get the whole number square at the left hand side of this equation, and we get the power of 17 at the right hand side of this equation. Okay? So there is a kind of relationship between this power and this square, as well as this one. So the most of the time, the easiest way to solve this kind of this problem, we are going to use the congruence notions. Okay, so you are going to check which appropriate module we can use here in order to divide both sides of this equation to make the same remainder for both sides of this equation in order to get the solution for this equation. Okay, as you know, if you get the same remainder for both sides, that means you have a solution for this equation. If you have a different remains, which means the equation does not accept any solution. Okay, that's the essential point that we are going to base on. Okay, so now let's get started. I see it here. If I'm going to use number 9 as a module, it will be appropriate value. It will be appropriate one for this equation, because if you divide this one by 9, this one is divisible by 9. This 17 to the k, if I'm going to put it and split this one into two terms, 18 minus number 1, I get 18 divisible by 9. I will have a good idea how to deal with this one. Okay, so as you know, 225 is the same as 3 squared is multiplied by 5 squared. Okay, I will be used number 9 because this one is divisible by number 9, as well as this one, but this one is not divisible by 9. But there is a trick how to deal with this number 9 as a module. So 17 will be split into two parts. I get 17 equals 18 minus number 1. So 18 will be divisible in number 9. I will be left with minus number 1 to the k. Okay, I will leave it like this. We will see what's going to give us. Okay, so by reducing the whole thing to the module 9, I get here n squared. I get 0 here is a congruent to 18 minus number 1 to the k. Okay, which is a congruent to minus number 1 to the k. Okay, mod 9. So the next thing up, in order to make the comparison between the right and the left hand side of this equation, we are going through charts. Okay, so here is the chart. Here is the following values. I get k, let's put this one in general. I get k squared. Okay, here is the following values: 0, 1, 2, 3, 4, 5, 6, 7, and so on and so forth. Okay, less is going to be reduced to the mod 9. Okay, let's see the following values. I get 0, I get 1, I get 4, I get 9. 9 is 0, is a remainder 0. I get 4 squared, which is 16. 16, I have a choice here. I can put it as a 7 remainder, because from 9 to 16 we get 7 as a remainder, or we can put minus 2 because we get 2 numbers in order to reach number 18. Okay, let's put it as a positive reminders in order to make it more clear here. Let's put 7. 4, 5, I get 5 squared, which is 25. 25, between 25 and 18, you get number 7 as well. Or you can put it minus 2 because we get 27. 27, because 27 is divisible by 9. Okay, for 6, I get 6 squared, which is 36. 36 will be divisible by 9, which is 0. For 7 squared, I get 49. 49, I have 4 more 45, because 45 is divisible by 9, so the remainder number 4. Okay, let's put one more. 8 squared, which is 64. 64, I get one more 63. Okay, so if you take a look now, we are going to stop here. This is small. We are going to stop here because we see kind of patterns here. We get 0, 1, 4, 0, 4, 1. Okay, as you increasing up the values of k, you will have a kind of repeating here. 0, 1, 4, you get 0, 4, 1. So this one, so which means k squared is belongs to this set. 0, 1, and 4 as well as 7. Okay, now we are ready to make the comparison between these values as a reminders of this n square and the right hand side of this equation. Okay, so what's the statement in order to make this statement true? Okay, if k is odd here, never ever you will see the reminders equal to each other here, because you get -1. We don't have the -1 here. But if k is a even, I get number 1 here. We already have number 1 here. So which means k must be even. K must be even. Now if it's even, let's set k equals 2m. Okay, now let's put this value of k and insert it back into the original equation and factor out these two terms. So I get here n squared plus 225 equals 17 is raised to the m. Okay, let's move over this n squared to the right and leave 225 to the left. I will get the following. I get 17, and then also at the same time I'm going to factor out, after moving over this n squared to the right, I get the difference of two squares, and I will factor out that in the form of the product. I get 7 to the m minus n factor 17 to the m plus n equals 125. 125 is the same as number 1 is multiplied by 3 square is multiplied by 5 square. Okay, so now we get this term is odd. This is odd. Of course this is odd and odd because we have the right hand side of this equation is odd also. Okay, so in order to solve this equation we'll have at least 3 possibilities here. Okay, but we are not going to do that. I'm going to use a small trick here in order to make the solution and in order to find the solutions quickly. Okay, so in order to deal with the product, I'm going to deal with the sum. Let's check if I'm going to sum these two terms, this product. I'm going to sum this one and this one. I get n cancelled out. I will be left with 2 times 17 to the n. Okay, so I get 2 times is multiplied by 17 to the n, like this. Now I'm going to set all the possibilities of this product. So I get, if m equals 1, I get 2 is multiplied by 17, which is 34. This one, if m equals 1, I get another possibility, which is 2 is multiplied by 17 squared, which equals 578. Okay, I'm going to stop here. This is if m equals 2. I'm going to stop here because this number, it seems, is going larger and larger than this 225. Okay, we don't need the next one. Next one will be crazy high than this one. Okay, so we will have only two possibilities. Since this 575, since this number is larger than 225, so the only possibilities of this product, it can be a solution, which is this one, because you have only possibility left here. This one, it's impossible because it's greater than this one, so I'm going to take this one. So now I'm going right away to the solution. I get this product 17 to the m minus n. So as you know, because as we sum in here, I get 34 equals 9 plus 25. Okay, because we're using 9 plus 25 because we already have it here, because the values of this product must be taken from this product. Okay, so I take 3 square, which you have here, as well as 5 square, which we have here also. Okay, the sum of this is given as 34. So you cannot take any other values in order to make this sum true. Okay, because if you take number 1 as a minimum value, which other sum can make you this 34? You cannot have it here. Since this term is smaller than this one, I'm going to give small value for this one and the bigger value for the other one. Small value is 9, but the big value is 25, which is 17 to the m plus 9 equals 25. Okay, Now I'm simply going to solve this equation. So adding first one and the second one, I get an eliminator. I will be left with 2 times is multiplied by 17 to the m equals 34. Dividing both sides by number 2, I get here 17 to the m equals 17. This one is telling us m must be equals number 1. Okay, taking the value of 1, taking the value of m and insert it back to the k here, I get the value of k. I get k equals 2. So in order to find n, I'm simply going to plug m into this one to find n. Okay, so I get here, I get 17 minus n equals 9. Moving over 9 to the left and move over 9 to the right, I will be ended with 17 minus 9, which equals 8. Okay, so I get the solution n equals 8 with k equals 2. This is the only solution that I found. So I have finished with this video. Don't forget to hit the subscribe button and support the channel. Thank you for watching. I will see you next video. Bye.